Buffers are substances that minimize change in the concentration of protons and hydroxide ions. All that means, really, is that buffers prevent change in pH. At the bottom of the screen is an example of a buffer. Buffers are made up of a weak acid, which is a proton donor, and its conjugate base, which is a proton acceptor. And this equation will run in both directions to prevent dramatic changes in pH. It will run to the right in response to a rise in pH, and it will run to the left in response to a drop in pH. As an example of what a buffer does, we can use human blood, which has a buffer, and pure water that doesn't have a buffer. We'll take 1 liter of each of these substances and add 0.01 moles of hydrochloric acid. The addition of the hydrochloric acid to 1 liter of human blood will cause a change in pH from 7.4 to 7.3. The addition of hydrochloric acid to pure water will cause a change in pH from 7 down to 2. The reason that human blood prevents such a dramatic change in pH is because it contains a buffer. Now, if we focus on the illustration here in the center, we can illustrate how a buffer works. Human blood contains a buffer, and under normal circumstances, if we were to add an acid to human blood, initially the proton concentration of blood would increase. But since we have a buffer, it prevents that increase from being so great. The protons in the solution will combine with the conjugate base, as shown in the equation at the bottom. Those protons will combine with the conjugate base and form more of the weak acid, so that the proton concentration doesn't increase so much. Here in the flask, you see the protons moving and combining with the conjugate base, forming more of the weak acid, and this happens over and over again to prevent the rise in proton concentration from the addition of an acid. If we add a base, the opposite should happen. Under normal circumstances, the addition of a base will cause a decrease in proton concentration, but the buffer will prevent that decrease from being so great. The equation will run in the opposite direction. On the left side of the equation, the weak acid will start to donate or give off protons into the solution. And that way, the initial drop in proton concentration will be overcome by the donation of protons from the weak acid.